12.2. 12.1 is kind of boring. It's organization of data, and we'll talk about that as we go through some of these sections. So I'm just going to hit the major points. It's in the stats section, and it is called measures of central tendencies. Is it AN or EN? Tendencies. Now, let's talk about what the heck stats is to begin with. I think this marker is done. Statistics is a field of math. You can actually get a degree, a 2-year degree in statistics, and get a job starting at about $50,000. In a manufacturing plant, you would be sampling, stuff that comes off the line, seeing how many of them are good, seeing how many of them are bad, and they pay you about $50,000 a year just to do that. Well, kind of cool. It's a very boring topic. I would never want to do it myself because I find it very boring. But it is kind of important in the real world. So measures, statistics is, you have an idea. This is how scientifically it's used. You have an idea and you want to test it out. So you set up an experiment. You collect data from your experiment, and then you take your data and you organize it. You calculate some values on it, and then you analyze it. We're going to deal with everything up to analyzing. We might not do a lot of analyzing at the very end, but we're going to not gather it. Gathering statistics is kind of boring, and I'll talk about it a little bit. I'm going to give you some data sets. You're going to organize it. You're going to calculate a few things about it, and then we'll do some problem solving about the possibility of something actually happening. So gathering statistics is actually a very tricky field, and since the political season is upon us, I have to talk about this. There are ways of lying with statistics. There are ways of phrasing questions so people will answer them the way you want them to answer it. There are professional people out there that write questions very explicitly to even make a Democrat answer things in a Republican way or vice versa. So when you hear about all these statistics, be really careful of how they phrase things. And usually when they put it on the news, they shorten it up. And the question that they ask people is usually a little bit longer. And they kind of imply things that really shouldn't be implied. So take all of these political things with a grain of salt, that there is a side, and unless you get one that is totally, ignorant of both parties or don't care about both parties, and they just look at information and they don't want to force it one way or the other, like political ads, they'll force it one way or the other. So you want to go with, what do they call them? Independent studies, ones that are think tanks or people that go out and actually do these without any regard of political affiliation. Because you can lie with statistics, and too many people are drawn into that. All right, so if we're given pure data, there are 3 things that we always start off with, and they are called the mean, the median, and the mode. And what's funny is people screw these up, because most of them you were taught in like 8th grade, I think it is, somewhere around there. The mean has another word that's associated with it. The problem with the word average is it gets used in different situations. For instance, probably the most common one is if you say, what is the average U.S. Income of a family of 4, blah, blah, blah. And when they say that the average income of the United States is about $45,000, something like that, per year, are they really talking about the mean? And the answer to that is absolutely not, because the average salary, if you took everybody's salary, added it together, divided by how many people made those salaries, is closer to 150,000. And obviously that is way too high. Why would it be that high?
Because there's other people that make more.
Yeah, Warren Buffett, billionaire, he makes a lot of money, and if we just did an average, that brings the average salary up, well, the mean salary up. So when you use this word average, it actually gets kind of split between these two, between the median and the mean. When we talk about the average salary, we're really talking about the median salary. If you lined up everybody, you'd pick the person in the middle. And that's why it's about 42 to 45,000, because if you pick the person in the middle, that's about how much they make. And in that case, median is a better measure of central tendency. So the word average would be meaning the median in that case. If we're talking about average grades, that's usually more a mean score, where you take everybody's grades, you add them together, and divide by how many students there are. So this word average kind of gets split between those two words, and that's why we don't use it for the word mean. I'd rather you say mean, because that's a very specific definition, where average can be meaning almost any one of these. All right, so the mean is basically add data, can I spell? Data all up, divide by how many? Paraphrasing what it really means to do. So what is data? Data, you can pronounce it either way. It's information. It's usually numbers, but it could be names, places, it could be anything. They're sets. Remember sets from way back when? They're literally sets of values or sets of elements. Now, the problem with the word data is it actually means both. It means the set of elements. It also means a singular element. For instance, if I gave you a data set, 1, 2, 3, 4, then the set of 1, 2, 3, 4 is data, and the number 3 is also data. So it's singular and it's plural. It's a very funny word, so you have to be careful which one do you mean. Do you mean the singular data, or do you mean the entire data string, or the data set? Median literally means the middle, kind of like the median of a highway, the middle. Mode is most frequent, the one that happens the most often. That happens the most often. All right. Now, working with these, it's really not that hard. It's just sometimes the set of data is written differently. There is data that is written as lists. There is data that is written in a bar chart, if you want to think of it, bar graph. There will be data in a frequency chart. That's the one that confuses most people. So let's talk about the different possibilities. Yeah, for example, if I give you a data set, I usually leave off the squigglies and just write the numbers. So find mean, median, and mode for 5, 17, 12, 13, 12, 20, 16, 9, 5, 11. Now this could have been a person wandering around the mall asking, how many cups of coffee do you drink in a week? And when they ask the first person, they say 5, and another one 17, and they just give these random numbers. So they come in any order. Before you do anything, there's 2 things you have to do to begin this. Number 1, how many are there? Number 2, put them in order. Because if they're out of order, a couple of the answers come out a little weird. So, first off, how many are there?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So I'm going to go off to the side and say n equals 10. What does n represent? Do you remember from chapter 2? Begins with a C.
Cardinal number.
Cardinal number. So this means exactly the same thing. N is the cardinal number of the set. The number of elements in the set is 10. All right, the second thing is get it in order. So smallest number is 5. Now in this case, unlike sets, we're allowing repeats. So 5 happens in the first plot and near the end. So I can take care of both of them. What's next?
11.
11? 9. I worry about your number orders then. Next up, 11. Next up. Next up.
It's 2, 12, 12.
Oh, there's 2 12s. Okay. 2 12s. 13. 17?
16.
Okay. Who's lying to me? 16, 17, 20. I'm really worried. Is that the biggest? Now, because you screwed up, we have to go through and make sure there's 10 elements. 1, 2, 3, 4, 5, 6, 7. Skip that one. 10. So we still have 10 elements. That is a good check because it's really easy to miss, skip, or duplicated numbers or skip over a number. So be really careful there. All right. Now, how do I find a mean?
And I remember the.
All right.
10.
I'm sick of saying add up all the numbers and
Well,
divide by 10.
add, divide.
So mathematicians hate things like saying add the data all up and divide by how many. They don't like saying that. So they have a symbol for it. Symbols. And the symbol for the mean is add up. If you've ever seen a spreadsheet, you've seen this button. It's called the summation. And it literally means add them all up. When I write X, X represents two things. Well, actually it represents one word, data. But data represents the entire set, but it also represents each individual one. So this literally means add them all up, add up all the data, and divide by how many? Well, what's how many represented by? N. So this is the formula for mean. Add up all your x's and divide by the cardinal number. So if I add up all my numbers, what do I get?
120.
120. And I want to divide by?
10.
Okay, that's weird. I usually want decimals, so this comes out even.
11.
This comes out to be
11.
12.
12. I don't know how I'm getting answers from.
Because you're using your calculator instead of your brain. So this comes out to be 12. Now, because they can come up with decimals, and I really did want this one to come up with a decimal, you're going to be accurate to one more decimal place than the original data. One more decimal place than the original data. The original data had no decimal places, so your answer is going to have one decimal place. So I'm going to actually put in 0.0. Even though it doesn't change the value, you're saying that it is accurate to the tenths place. We're going to be talking about accuracy for a little bit. So the mean of this data is 12. Okay. Next up is median.
Question real quick.
Go for it.
So we must put the point at the 0.
Has to be accurate to one more decimal place than the original data. I'll come up with another one in a second. All right, the median. How do I find the median? Well, the median you can do elementary style. Elementary style is you take your two fingers, you put it on the outside of the data, and you count in until you get to the middle. So 5 and 20, 5 and 17, 9 and 16, 11 and 13, 12 and 12. Now we're landing on two values. Where's the middle of those two values? Well, between them. Well, how do I find what's between them? You add them together and divide by 2, which will be 12, but the whole process is you're going to go 12 plus 12, and you're going to divide by 2, which is 12. 0.0, why not? Be accurate. Now that's really nice. When the mean and the median are the same, something special is going on. Sort of, except for one problem. Mode is going to throw my niceness off. What is the mode of this data? Well, it's the one that happens the most often.
5 and 12.
5 and 12. This is what's called bimodal. You have to say both of them because they happen exactly the same amount. So 5 and 12 are the mode, and literally it's called bimodal. What if there was no repeated numbers?
No mode.
No mode at all. What if we had all of them repeated twice?
All modes.
No mode.
No mode.
No mode. Same thing, because none of them are bigger than the rest, right? They're all the same. I won't ever do that, so don't worry about that. So, the special case actually would have happened if the mean, the median, and the mode were exactly the same. Then we can say that the data is normal. And we'll talk about that later. Okay, so that's a simple example. Let's make it worse. Oh, trust me, it doesn't get worse other than the numbers you have to deal with. Nothing really gets bad with statistics. Let's make some decimals up. 0.25, 0.5, 1.7, 3.8, 0.8, 1.25. So it's one more. 1.1. Okay. Now, before you even start jumping into mean, median, and mode, the two things you should take care of first. How many are there? And put them in order. How many are there? Put them in order. So how many are there? 7. So n equals 7. Next step up is put them in order. Smallest?
0.25.
0.25, that's fine. Next?
0.5.
0.5.
0.8.
0.8.
1.1.
1.1.
1.25.
1.25.
1.7.
1.7.
3.8.
3.8. No mistakes?
Yes,
Are you sure? Okay. 1, 2, 3, 4, 5, 6, 7. Okay. So, we know how many there are. We got them in order. Now we can start answering mean, median, mode. Now this gets nasty because the numbers are decimal, but thank God you have a calculator. How do I find the mean? Well, I add up all my data points and I divide by how many there are. And when you add up all these nasty little numbers, you get
9.4.
9.4. Confirmation? I don't trust anybody with a calculator, including myself. 9.4? Okay. Divided by?
7.
This one's not going to come out nice like the last one.
I mean, that's what we go.
Give me a few decimals and I'll tell you.
1.343.
3, 4, 3.
That's it. You said go one more than what we got in the number.
Well, I was just going to write down the number and then talk about that.
343.
3, 4, 2, 8, 5, 7. 2, 8, 5, 7, blah, blah, blah. That's just what's on your calculator.
Oh, you want us to write them out?
No, I want to talk about what I want you to write. Now, the maximum number of decimal places in my data, 2. The answer is going to have 3. So I need 3 decimal places. So I need to round this to the nearest, what's that, tenths, hundredths, thousandths? So 1.343. So this is the answer I'm looking for. 1.343. Accurate to one more decimal place than the original data. Okay, median. Median. The median, well, take your fingers if you want. 2, 5, 3, 8, 5, 1, 7, 8, 2, 5, 1.1. So 1.1 is kind of all by himself there as the median. Why did the other one have 2 for the median and this one only has 1 for the median? So odd number of data points, you're going to get exactly one number as your median. Even number of data points, you're going to get 2 numbers you have to add together and divide by 2. Now, do you think the finger method is always going to work? So there's got to be a better way of doing it. So how do you find the middle of numbers?
Divide.
Divide by
2.
2. So what do? Take how many there are
And
and divide by 2. So let me find this 1.1 a different way. There are 7 numbers, right? Let me write it this way. N divided by 2. There are 7 data points. 7 divided by 2 is?
3.5.
3.5. Now, we're looking for a position. So this position has to have a whole number value. So what we're going to do is we're going to take 3.5 and move it up, round it up a few things that way. So this becomes the 4th position. Now, what number's in the 4th position? Well, here's 1, here's 2, here's 3, and look, lo and behold, 4th position is 1.1. It also works for an even number except for one problem. I'll do another even one in a second. All right, so the median is 1.1 either by finger method, which sometimes works and sometimes doesn't, or this little formula of n divided by 2. This one works. The book does it a little different than I do, but don't let that throw you. Mode?
No mode.
No mode. And don't be afraid of saying it. It's perfectly fine to have no mode. They all just appear once. Hey, this is fun. Boring, isn't
Again, your choice of words.
it? Go for it.
Underneath the median, where in the world do you get that?
If you're trying to find the middle of something, you always divide by 2. So n is how many numbers you're looking for, and you're looking for the middle element. So you're not looking at their values, you're looking at their position, what position they're in. I'll be doing that again. All right, one last example. Let's go back to even. Let's keep it kind of short. 2, 2, 2, 3, 3, 3, 4, 4, 4, 4. 4. 1, 2, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers there.
Just there in order.
Oh, hold on. Let me change this one to a 4.
That only change?
The fourth 3 just changed to a 4. All right, so there are 12 numbers here. N equals 12. They're already in order, so you don't have to put them in order, which is kind of nice. So let's just go finding things. The mean. All right, add them all up. Divide by how many?
12.
Add them all. Oh, I know there's 12.
Oh,
So, well, divide by 12.
$3.3.
What is it? No. What's the sum?
Oh, 39.
39. And 12 divided by 30. Oh, I'm sorry. 39 divided by 12?
3.25.
3.25. So, we want just
3.3.
one decimal place, so it's going to become 3.3. So the mean of this is 3.3. Let's go for mode next. Do median last. What's the mode?
4.
It's 4. It happens, what, 6 times? So it's definitely 4. And then the median. Now, I want to do it with the formula. And then we'll make sure it works by the finger method. How many are there? Divided by 2. So this would be 12 divided by 2, better known as 6. This is where you have to remember, if you have an even number of data points, you're looking for 2 numbers. You're not just looking for 1. So I'm going to take the 6th position and the next one. So there's always a little adjustment to this formula. Over here you had to round it up to get to your number. Over here you're getting your answer and you're taking the next one. So where's the 6th position?
So, hold on, Mr. Gaffney.
What?
So when you get like that, the median on the left-hand side, when you have to round up, you just get 1. But when you come out with a
Sixth
positive number on
position
that
is
side,
You
The
take that
answer
one
and
and the
the
next one. All right.
6 position.
With odd, you're only looking for one value, and this gives you the singular value. With the even, you have to remember you're looking for 2 values, because there's going to be 2 numbers sitting in the middle. All right, the 6th one is going to be 1, 2, 3, 4, 5, 6. Here's your 6th position. And then the next one is your 7th. You'll notice why I changed that 3 to a 4, because I wanted them to be different. Okay, so these become your medians, but I really want just a median. So I'm going to take the 6th one, which is 3. I'm going to take the 7th one, which is 4. I'm going to add them together and divide by 2, which turns out to be...
3.5.
Ah, don't ignore that. What is it?
3.5.
3.5. So your median is 3.5, your mode is 4, and your mean is 3.3. Relatively close, but not exactly the same. Oh well, life goes on. So, is that as hard as it gets?
Probably not.
Probably not.
The number of cardinal numbers.
The what?
The number of cardinal numbers.
Well, there's only, the cardinal number is 12.
I know, but it seems like that would be the only thing that can make it harder.
Oh, how many there are? Oh, yeah. The bigger it gets kind of nasty. So, while we're on this one, let's talk about a frequency chart. Instead of writing 222, 333, 4444444, there's an easier way to do it. And these charts, I do mine vertically. The book writes theirs horizontally because it saves space in the book. But for paper purposes, vertical's fine. And what you do is you say, well, here's my x's, my data values, and over here is going to go their frequency, or their individual modes. And the numbers that we're dealing with are just 2, 3, and 4. That's all we're dealing with. 2, 3, and 4. What's the frequency of 2?
3,
There's 3 of them. What's the frequency of 3?
3,
3. 4?
6.
It has 6 of them. Now, when you're looking at frequency, these are not data. This is just telling how many of the data we actually have. So the data is in this first column. Our data are 2s, 3s, and 4s. Don't get confused. Most people that see this chart confuse the frequency as data, and it messes up a bunch of answers. Now, if we're looking at this frequency chart, and I want to find the mean, I want to add up all the values, but all I have is this 2, 3, 4, and 3, 3, 6. So what I need to do is somehow figure out a way of doing that. Well, when you type this into your calculator, did you type in 2 plus 2 plus 2?
No,
What did you do?
6.
No, what did you type in? If you were going to type it in the calculator,
2
2 times 3. And here, instead of typing in 3 times 3 times 3, or 3 times, 3 plus 3 plus 3, 3 times 3. And then instead of adding 4 6 times, you would go 4 times 6. And if you look at this, 2 times 3, 3 times 3, 4 times 6. So to do the mean, the way you would set it up is this. And then you would divide by how many, which was 12. It should give you the exact same answer. Because multiplication is multiple additions. That's how it was defined. Alright, mode is real easy. You go down the frequency and you find the largest number. And the largest number in the frequency is? Largest number in the frequency is 6, and it's related to the data value of 4. So you go, oh, here's 6, and it's related to it. You have to go back to a data. This is where people answer mode is 6, because they're looking for that largest frequency, and they see that number 6, and they write it down as their answer. But you always have to answer as a data value, not a frequency value. Then the trickier one is, how do I find the median using this chart? Well, you're going to have to add on to the chart to figure this out. What you do is you go over here to the side, and you do what's called a cumulative frequency. Basically subtotal. You're going to subtotal your frequencies. So the subtotal for the first line is 3. The subtotal as you come down to the second line is 6. The subtotal as you get to the last line is 12. Because 6 plus 6 is 12. So basically you take the first number, you write it down, then you go 3 plus that 3 gives you 6. And then you take that 6 and add on 6 and it gives you 12. So that's what's called a cumulative frequency. Now I know that my data values are between the 6th and the 7th one. Well, as we go down the cumulative frequency, when do we run into 6? In the middle, and it's associated with 3. Where do I run into 7? Well, definitely after 6, which would push me down to 12, which would give me the 4. And then I take my 3 and my 4 and I add them together and divide by 2. So that's...
I don't know about that one.
You don't like that one?
No.
If it's listed out, right? If it's listed out, you would go and look for the 6th and the 7th element. So if it's listed in a cumulative frequency, is the 6th or 7th element in the first 3? No. Is it in the first 3 to 6? Yes. I'm looking for the 6th element. So 6 becomes one of my answers, so I choose 3 as my data value. But I'm also looking for 7. Is 7 in this line? Heck no. I have to move down to the next one. Even it goes up to 12. So this one has 7, 8, 9, 10, 11, and 12. So 7 is in here, so I pick 4. 3 and 4 I pick, I add them together, divide by 2. Oh, let's do another cumulative frequency.
7.
No, you take 12, divide by 2.
Two.
Oh, yeah. Let's try one more, a little uglier. A community college instructor is concerned that his students are coming late to class, so he wants to collect some data for this. Now, frequency. If you are 0 minutes late to class, what are you?
On time?
You're on time. So let's say 14 people were on time. Up to 5 minutes late. So this would be anybody that comes 1 minute late to 5 minutes late. Let's say there were 7 of them. 10 minutes late, 5 of them. 15 minutes late, 8 of them. Imagine those students. What are they learning? Nothing. 20 minutes late, shouldn't even showed up. I had one person show up 45 minutes late for an hour class. How much time is left in the class? 5 minutes. I looked at him and I'm like, are you going to mark me present? You're funny. 25 minutes late. Let's say there's one person that was 25 minutes late.
Well, no show.
No show. Absent.
Yeah.
That's what I would mark them as, absent, even though they were there. Actually, I think my rule is if you're more than 1/3 of the class late, you're absent automatically. Okay, so let's see here. Let's find the mean. Now the formula changes a little bit. The formula from the table standpoint is the data value times the frequency added together. So the way we're going to write that is the summation of my data value times the frequency. So that means you have to multiply the data times the frequency first, take all those answers and add them all up. That's what the summation means. Now what am I going to divide by? Well, I still want to divide by the cardinal number, but if it's in a chart, what am I really adding up? The frequencies. So I'm going to literally write that in there. I'm going to add up the
37.
frequencies. So the formula just changes a little bit. It means exactly the same thing. Add up all the data values, divide by how many. The problem becomes people don't think of the frequency as the number of values. I have seen people go like this. Oh, I get the answer to the top is, what was it over here? 39, and they divide by 1, 2, 3. Because they're just counting how many data points are in the chart rather than how many are in the, or how many the chart actually represents. So be really careful of that. So in this case, we're going to get 0 times 14, which is
0.
no, we're not even going to count that one, but I'll put 0. 5 times 7?
35.
10 times 5? 15 times 8? 120. 20 times 2? And 25. And we're going to divide this by,
37.
where'd you get 37?
14, 21, 26.
You add up all of these. This becomes your sum of your frequency is 37? 37.
Yeah.
All right. So you add up all these numbers and you divide by 37. I highly suggest you don't do it this way. I highly suggest you go on your calculator and go 0 times 14 plus, 5 times 7 plus, 10 times 5 plus, 15 times 8, and just string it all in there, hit equals, get the sum to be
270.
270, and then divide it by
37.
37. Just don't put the divide by 7 in your calculator. Get your answer to the top first, and then turn around and divide by 37.
7.3.
7.3. Why is it 7.3 and not anymore?
It's a place, one place above.
There are no place values over here, therefore we have to include 1. Okay, so that's the mean. Median is the one you're not going to like. Median. The median requires that cumulative frequency part. So you go off to the side here and you cumulate your frequency. So cum frequency.
Really?
Really? So the first one is
14.
14. The next one would be
21.
21. The next one would be
26.
26. The next one would be
34.
34. 36. This last number better be the exact same thing as the number of elements in your set. Otherwise, you can do some calculation wrong. Now, how do I find the median?
I don't know.
What's the formula?
N over 2 equals.
N over 2, which is 37 over 2, which is 7.3.
Oh, no, I got it wrong. Don't keep this
Is
18.5.
18.5. Now, what do I do with this?
You
Well,
You
the
find
median
it-
is looking for the middle number
You
of
find it. You
numbers.
find it over there.
We have an odd number of numbers, so therefore we're finding how many values?
1.
1. this is a position, and there is no position 18.5th element, so we have to move it up to 19. So I need to find where is the 19th element in this chart.
5.
So, is 19 14 to down? No. Is it 21 to 14?
Yes.
Yes. So I take 21 and I move over to the data, which would be data. Data, this is frequency. Data is 5. So the median here is 5. Oh, by the way, box your answers because otherwise you have a bunch of numbers on your paper and I don't know which one your answer is. Okay. And then the easy one. Mode.
0.
And mode is 0. That's a weird mode. Well, you go down your frequencies. What's the largest frequency? 14. And it's associated with?
0.
0. So therefore the mode is a boring 0. Most students, modal-wise, were on time. The median lateness of the student was 5 minutes. The average lateness of each of the students was 7.3 because there was this, one 25-minute late person. He kind of dragged the average in that direction.
That's okay. How you get the mode?
Mode, most frequent. You go up the frequency and you find which one's the biggest value. It happens at 14, so the mode is 0. It's supposed to be the easiest one to answer. How about...
You could always go the long way and list it out.
Oh my gosh, yeah. Sure, go right ahead.
This another example?
Lord have mercy.
I'm hoping I can do it right.
And it looks ridiculous already. So, Mr. Benoit,
Can we go back a book?
I can grab last. Give you the right answer.
Like, last time you said that.
Well, those formulas, it depends on which one works for you. The
Uh,
book works better for you, go for it. I'm just, last chapter, I know the book would work better for you. Let's see. Let's do it this way. 2, 5, 17, 15, 30. I have no idea what that's going to do.
you sure?
I'm positive. Yeah, that's what I wanted. Yeah. Okay. So let's start off with median. Now, in your calculators, to do this, just multiply and add them up as you go and come up with a grand total. So that would be your sum of your data times your frequency divided by the sum of your frequencies. So if you multiply, 60 times 2 plus 70 times 5 plus 80 times 17 plus 90 times 15 plus 100 times 30, what's your grand total?
34.8.
3480? 3480. Confirmation?
yes.
Yes?
Yes.
Okay. Divided by. Now, the mistake would be 1, 2, 3, 4, 5, because there's no 5 elements here. There's 5 data values, but that's not how many elements there are. So make sure you go over to the other side and go 2 plus 5 plus 17 plus 15 plus 3, better known as the sum of your frequencies, which is
42.
42. All right, so we're going to divide by 42, and we get an answer of
82.9.
82.9. Put a box around it because that's my mean. Make sure you label your answers. If you just write 82.9 someplace on your paper, I can't tell what it is. I don't know if you mean the mean, the median, or the mode. Later on, there's some other calculations we need to do. So make sure you get associated. So if you have to, write this. Mean equals 82.9. Because all of these things are just going to be numbers. A bunch of numbers lying all over the place, and you have to label them really, really well. Worse than the last chapter with the money stuff.
Let's do Lauren?
Yeah.
What do we call the number where we have to take, all of these numbers and add them? No, we multiply them.
Multiply them and add them all together.
Yeah, what do we call that?
Total.
The total.
If you want, just the total of the data.
Okay.
It doesn't really have a specific name, I don't think. Median. Alright, median's formula is n divided by 2. N in this case is?
42,
42 divided by 2 is?
21.
But it's even. So we're going to take the
So that
21st
first
element
and the next one.
and the 22nd element. So we're going to take the 21st and the 22nd element in this list. To find the 21st and the 22nd element, we need to do the cumulative frequency.
Oh.
So the cumulative frequency starts off with 2. 10. Not multiply. Add. 7.
24,
24.
39,
39.
42.
And I hope 42. Yeah, don't multiply. Where does the 21st element happen? Does it happen in the first line?
No,
Second?
no.
Third?
Yes.
Yes. And the 22nd happens here too.
Yes.
Because this goes from 7 to 24. So in this bracket here will be 8, 9, 10, 11, 12, all the way up to 24. So 21st and 22nd happen in this group, which is associated with 80. So the median for this data is 80. We don't even have to add it and divide by 2 because it'll be 80 and 80, and 80 plus 80 divided by 2 is still 80. So my median is 80. The easy one, mode.
90.
The one that happens the most often happens at 17, which is associated with 80. And there's my mode. So 80, 80, and 82.9. Really close together. When those numbers become exactly the same, we're going to be talking a lot about that in the next few sections. It's called normal grades. Normal grades.
How you say you found the mode?
How do you get the mode?
You go up the frequency. Mode means what? Most frequent. What's the largest frequency?
24.
What's the largest frequency?
17.
17.
Okay.
And what's the data value associated with 17? 80. Never answer frequency. Always answer data. Always answer data.